Not only we use integral to find the displacement and total distance, we also use integral to find total accumulation. So for this example regarding potato consumption, from 1970 to 1980, the rate of potato consumption in a particular country was C of t equals 2.2 plus 1.1 to the power of t millions of bushels per year. Now notice, it says bushels per year, which means that it is a rate of change of bushels per year. With t being years since the beginning of 1970, how many bushels were consumed from the beginning of 1972 to the end of 1973? So basically, we'll find the total number of bushels that were consumed from beginning of 1972 to the end of 1973. So we could think of it as 1970 represents when t equals 0, and 1971 represents when t equals 1, and so forth. And we're looking for total consumption from beginning of 1972 to the end of 1973, which is like beginning of 1974. So basically, we're looking for total consumption of potatoes from 2 to 4. And what goes inside? What's the integrand? It's 2.2 plus 1.1 to the power of t dt. Now this will give you the total consumption of potatoes from 1972 to 1973. And you can use your calculator and we'll approximately give you 7.066. And what is the unit of measurement? It says millions of bushels. So it should be 7.066 millions of bushels. Now let's take a look at this example. From noon until 6 p.m., the rate at which people enter an amusement park at time t is given by E of t, which is this graph right here. So this represents the rate at which people enter an amusement park. So in order to find the total number of people that enter the park from 0 to 6, here the 0 represents t equals 6 is 6 p.m. and t equals 0 represents noon. So from noon to 6 p.m., if you want to find the total number of people that enter the park, what you got to do is you need to find the integral from 0 to 6 of E of t dt. And how do you do that? Well, that is the area underneath the curve, if we recall. You got to find the total area of this. So in order to do that, what you could do is you could find the area of this rectangle right here. And then you could find the area of this triangle and find the area of this rectangle and find the area of this rectangle and find the area of this triangle. And there's other ways too. And that's going to be 3,200. Now, people are also living at the rate L of t, which is this expression right here. So what is the total number of people? So what is the total number of people that left the park from 0 to 6? Well, that's going to be integral of 50 quantity 2 plus t squared e to the negative t over 5 dt. And You want to use your calculator to find this, and you will get approximately 2,106. Now they want you to find if 3,000 people are in the park at noon already, how many people are in the park at 6 p.m.? Rounded to the nearest multiple of 100. So 3,000 were already there. And 3,200 entered the park during those 6 hours. And then approximately 2,106 people left the park. So it gives you 4,094 people. But they want you to round it to the nearest multiple of 100. So approximately 4,100 people are in the park at 6 p.m. Now we need to find gallons pumped from rate data. A pump connected to a generator operates at a varying rate, depending on how much power is being drawn from the generator to operate other machinery. The rate, gallons per minute, at which the pump operates is recorded in 5-minute intervals for 1 hour as shown in table 8.1. How many gallons were pumped during that hour? So basically, we want to find the total number of gallons that were pumped within that 1 hour. So we want to find integral from 0 to 60 of r of t dt. But for this problem, they only gave us a table, and we don't have any formulas or graphs. So what we need to do is, since they gave us a table, we need to go back to using trapezoidal rule. Do you guys remember trapezoidal rule? It just says if you want to integrate from 0 to 60 of rt dt, what you got to do is you got to do b minus a over 2n, where n is a number of trapezoids, times f of the first term plus f2 times f of the second term plus 2 times f of the third, so forth until you get to the last term. Now notice the first and the last term do not have 2, if you recall that from trapezoidal rule. So what is our a? Our a is going to be 0, and our b is 60. So we're going from 0 to 60. Now, what is our number of trapezoid? Well, it says 5-minute intervals. So in order to find n, which represents the number of a trapezoid, we got 1. From 0 to 5, we got 5 to 10, 2, 10 to 15, 3, and so forth. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n represents 12. So setup will be 60 minus 0 over 2 times 12. And then what is our f of 0? Instead of f, we have to use r, so we got to do r of 0 plus 2 times r of 5 plus 2 times r of 10, and so forth. And we have to go all the way up to r of 60. So it's going to be 60 over, actually it's 30 over 12, which is going to be 15 over 6. And you can reduce that further, 5 over 2. Yeah, let's change it to 5 over 2. So what is our r of 0? R of 0 is 58. Plus 2 times R of 5. R of 5 is 60 plus 2 times R of 10, which is 65, and so forth. You have to continue all the way up to R of 60, which is going to be 63. And you calculate this, you will end up getting approximately 3,582.5. So total amount of pump during the hour is about 3,580 gallons of water.